Hi everyone, this is the help video for the Unit 4 test on multi-step percent. So in this unit, we went over solving percent problems, different kinds with different formulas. We're going to review some of those today, proportions, and then converting between units. So the first question that we're going to go over today is on simple interest. And in this unit, we did a lot of word problems, a lot of real world examples. So your test will look very similar. It will have a lot of real world scenarios. However, the formulas will be provided for you. So you really just need to understand how to use the formula. So for this first one, this will help you with question number 1 on your test. Paul borrows $500 from a bank with 6% simple interest each year. How much will Paul need to pay back in total in 4 years? So let's look at our formula for a second. We have interest equals P for principal, R for rate, and T for time. So we can go ahead and set up our equation here. Paul borrows $500. So we are solving for the amount of interest. That $500 is our principal or our initial value. So we have 500 times our rate, which is this 6%. Now, anytime you see something in percent form, make sure to convert that to decimal form. So 0.06. So right now we have 500 times 0.06 times the amount of time is 4. So I'm going to use my calculator and I'm going to go ahead and multiply those values together. 500 times 0.06, which is our rate, times 4, which is our time. So the amount of interest that Paul accrued over this amount of time is $120. But let's pay close attention to what the question was asking us. It says, how much will he need to pay back in total? So in total means we need to calculate what the initial borrow amount was plus the amount of interest. So if we look back at the beginning, initially, Paul borrowed $500. So we're going to add that initial borrowing amount or the principal plus the amount of interest, which was 120. And we're going to add those together. 500 plus 120 is 620. And this is the amount that Paul would pay back in total. So again, using that formula, we're multiplying the principal times the rate in decimal form times the time. And then we are adding our amount of interest to our initial amount in order to find the total amount that needs to be repaid. Now let's go into our next set of questions. This is on percent change. And this will be helpful for questions number 2 and 3 on your unit test. When we're talking about percent change, we have the same formula that we can use whether it's percent of increase or percent of decrease. And that formula can be found up here. We're going to find the amount of change and divide that by the original value, and then we will convert that into a percentage. So find the percent of decrease from 6 to 5. So again, we are starting our fraction. Our numerator is the difference between those two numbers. 6 minus 5, oops, that was a little crazy. 6 minus 5 is 1. So I'm going to rewrite that. 6. And then now we're going to do our denominator or the bottom number of our fraction, which is the original value. So we're going to look at what was our starting number. And our starting number, it says from 6. So that's going to be our denominator is the number 6. Now keep in mind that anytime you see a fraction is a division problem. So we are going to take 1 divided by 6, and we're going to go ahead and divide that. 1 divided by 6. And when you divide that in your calculator, you're going to get something like 1.166666 on for forever, or you can write that as 1.6 repeating. And we're going to convert this into a percent. Again, in order to convert to a percent, you are going to move that decimal 2 spaces. So 1 over 6 is equivalent to about 16.6 So the percent of decrease from 6 to 5 is approximately 16 to 17% decrease. We're going to do the same thing with our next one. A movie ticket price changes from $10 to $12. So this is going to be a percent of increase. We started at 10, we went to 12. What is the percent of increase in the movie ticket? So we're following the exact same steps as before. Our numerator is the difference between those two values. 12 minus 10 is 2. That's our numerator. Our denominator is the original value. So what was our starting point? Our starting point here was 10. Just like before, now we can go ahead and divide numerator by denominator because a fraction is a division problem. So 2 divided by 10 is 0.2, which is equivalent to 20%. So the percent of increase in that movie ticket that increased from $10 to $12, that was a 20% increase. Now let's talk about tip and tax. And these questions will be particularly helpful when you're solving questions 4 and 5 on your unit test. A family goes shopping. They purchase a couch for $850.99. How much is the total cost of their purchase if the sales tax is 7%? So again, we've got some keywords here. We're looking for the total cost of the purchase. We've got the initial amount, and then we've got our tax rate. And again, anytime you see something in percent form, just go ahead and mentally convert that to a decimal because you cannot calculate something while it's in percent form. It has to be in decimal form. So we can go ahead and set up our problem. We are going to multiply our price of our couch times that tax rate, 0.07. And again, I'm using my calculator for all of these calculations. And so when I calculate $850.99 times 0.07, that gives me 59.57. And that's the amount of tax that the family would pay on the couch. But let's again keep in mind what the question is asking for. It says, what is the total cost of their purchase? So in order to calculate the total cost of the purchase, I need to add the initial amount of the couch plus the amount of tax. So I can go ahead and do that right here. $850.99 plus that amount of tax, which was $59.57. Again, I'm using my calculator. You will have access to the calculator while you take your test and the big test at the end of the year, so make sure you're comfortable. The total is $910.56. So again, when you're looking at these, be very careful that you're reading what the wording is. This one was asking for the entire cost in total, not just the amount of tax, but the total cost of the purchase. Here's our next sample question. So again, this will be helpful for questions 4 and 5. Simone is ordering dinner for her and her friends. She purchased an appetizer for $7.99. A meal for $40, and another meal for $25.50. Simone tips 21%. How much is the total? So this is definitely a multi-step problem. We have a lot of steps to do here. The first thing we would want to do, just like on our Daisy Donuts project, we want to find the total bill. So what was the total amount that was spent here? So we're going to go ahead and add up all the individual prices. So that's $7.99 plus $40 plus $25.50. And this is going to give us a total of $73.49. So again, I got that by adding together the individual amounts. That's our subtotal of our bill, so the amounts of just the food. Now I need to calculate the tip. So Simone wants to tip 21%. I'm going to convert 21% to a decimal, and I am going to multiply my subtotal by that tip amount, which is 0.21. So again, using my calculator, multiplying $73.49 times 0.21, and that gives me $15.43. So again, what does this mean? Well, $15.43 would be the amount of tip. So think for a second, have we still answered the question? The question actually asks, how much is the total? So we've calculated the amount of the meal, we've calculated the amount of the tip. Now, in order to find the total, we need to add together the amount of the food plus the amount of the tip. So I'm going to go ahead and use my calculator. $73.49 plus $15.43, and that gives me a total of $88.92. So there was a lot of steps in this one. I'll just recap very briefly. When I'm given multiple items on a bill, I want to add up all of the items on the bill. Then I'm going to calculate the tip by multiplying by the tip in percent form. Then because this problem asks for the total, I'm going to add the amount of tip to the initial value of the meal, and that will give me my total cost of this meal, which was $88.92. So again, these are notes to help you on questions 4 and 5. Now, this next set of questions will be helpful on 6, 7, and 8. So this is for 6, 7, and 8. The first one that we have here is proportions. I don't have a ton of space, so hopefully this will be a clean drawing. When we're solving for proportions, we're going to use cross multiplication. Cross multiplication. Super important that we understand how to do cross multiplication. All that means is we're simply multiplying the items that are across from each other. So we have 12 times x, which is 12x. And we have 3 times 32, which is 96. So again, multiplied across the equal sign, multiplied across the equal sign. 12x equals 96. Now I have a one-step equation. So whenever I have a one-step equation, my goal is isolating my variable, which in this case is x. And in order to do that, I need to divide both sides by the same value. So I'm going to divide both sides by 12. That's the only way to isolate my x. And this is going to leave me with x equals, and I have 96 divided by 12, which is 8. So the answer to my proportion is x equals 8. Again, I solved this by cross multiplying and then solving a one-step equation by simplifying using inverse operations. Next, I have a word problem also discussing proportions. Hugo sells handmade keychains online. Yesterday, he made 6 keychains in 30 minutes. Hugo wants to make 9 keychains today. If Hugo works at the same rate today, how long will it take him to make the keychains? So I'm going to go ahead and set up a proportion. Now, this one's a little bit different because I actually have to set up the proportion this time. So what we're going to do is let's just reread this and find the important parts. So it says yesterday he was able to make 6 keychains in 30 minutes. This is going to be our first fraction. 6 keychains. And I'm going to just put K up there just so we know that we're talking about keychains. 6 keychains in 30 minutes. That's my first part of my proportion. Now let's see what I'm comparing that to. Then it says Hugo wants to make 9 keychains today. If he works at the same rate, how long will it take him? So we're solving for time. Now, when we're setting up our proportion, it's very important that we put the same item that we're comparing in the same location in our proportion. So let's look at that first fraction that we wrote. We put the number of keychains in the numerator and the number of minutes in the denominator. We're going to do the same thing with our second fraction. The second fraction, I've highlighted it in pink. 9 keychains is what we want to make. So I'm going to also put that in the numerator. You see how our numerators are comparing the same item, keychain, keychain. In my denominator, I'm solving for how long it will take him. So we don't know the number of minutes, but I'm going to put that in the denominator because I am comparing minutes to minutes. Now that I've set up my proportion correctly by putting the same thing in the same location in our proportion, I can cross multiply. 6 times x is 6x. And then I have 30 times 9, which is 270. Again, I need to isolate my variable. To isolate my variable, I'm going to divide each side by 6. And this leaves me with x equals 270 divided by 6 is 45 minutes. So the question asks, how long did it take Hugo to make 9 keychains if it took him 30 minutes to make 6? And the answer to that it would take him 45 minutes to make 9 keychains. So again, setting up that proportion, cross multiplying, solving for the missing value. Last one is unit conversion. Again, this is for 6, 7, and 8 on your test. Unit conversion. Now, this is asking you how many miles are there in 10 kilometers. Now, solving unit conversion is awesome because you can set a proportion. That's one way you can do that. Or you can just multiply. So whenever you're doing unit conversion, multiplication is going to be the operation you want to use. I'm going to multiply the amount of kilometers by the rate of conversion. So I've got 10 times 0.6, and that equals 6. So that means in 10 kilometers, there are 6 miles, approximately 6 miles. So these are notes for questions 6, 7, and 8. We're almost done. We're on to question number 9. Question number 9 is talking about percent error. Percent error is a very similar formula to percent of change. A movie theater thought that they would sell 550 tickets to opening movie night. They ended up selling 500. What was the percent of error? So just like with percent of change, we're going to first find the difference between the two numbers, 550 and 500. The difference between 550 and 500 is 50. That's our numerator. Now, the denominator is, according to our formula that we can see here, is the number that's the actual number. So again, we're trying to find the percent error. That means someone estimated something would happen and it ended up being a different value. So our denominator is the actual number that occurred. So this problem says they ended up selling 500. They thought they would sell 550. They only sold 500. So our fraction, again, difference in the top, actual value on the denominator. And just like with percent of change, I can divide 50 divided by 500. And that gives me 0.1. And again, converting that to a percent, I can either multiply by 100 or move the decimal. Either way, that gives me a total of 10%. So the answer to this one, the percent of error, there was a 10% error in the calculations of their movie tickets. Again, this will help you with question number 9 on your unit test. And finally, we have discount. This is our last question on our test, except for that extra credit question. So this is for question number 10. These notes will help you. A sale rack at a store shows the entire store is 25% off. If I want to buy a shirt that normally costs $36.50, how much will I pay for the shirt, including the discount? So discount is a little bit different from tax and tip. Whenever we've calculated tax and tip in the past, we always add to find our total. But think about what discount is. If I'm getting a discount on something, would that increase the price or would it decrease the price of my item? Well, a discount is a decrease. So think about what operation we're going to need to use after we calculate the amount of discount. As always, I'm going to start with my amount of the item I'm purchasing, which was $36.50. Then I'm going to multiply it by the rate, whatever the percentage rate is, which in this case is 0.25. So I'm calculating right now the amount of discount. $36.50 times that rate of 0.25 gives me 9.125 or about 9.13. So this means that the discount on the shirt is $9.13. So we need to figure out, have we still answered the question? The question asks us, how much will I be paying for the shirt? So right now we know the initial amount of the shirt. The initial amount of that shirt is $36.50. We know the amount of discount, but we still don't know how much we're paying. So again, back to that thought process that we had before, how do we calculate discount? Again, if you're taking the discount of something, you're decreasing the value. So that would be a subtraction problem. $36.50 minus the amount of discount, $9.13. And we can use our calculator to solve. 36.50 minus 9.13. And that gives us a total of $27.37. So again, when you're calculating for discount, as always, calculate the amount by multiplying by the rate. But in order to find the amount that you would pay, you would need to subtract those values to figure out the amount that the discount actually provided to you. So now what? We have reviewed all 10 questions on the test. So make sure to complete your test. This is worth 20 points. There are the notes also posted in the gradebook if you need additional help. And as always, your teachers are here to help as well. So I hope you do great on your test. Reach out to us if you need anything.